Okay, I want to talk about a few ways of modeling multiplication that we've seen. And I should mention there is the one way that we've seen, which is just like to draw a picture of clumps of objects. So I'm going to look at 19 times 4 and look at a few different models. And when we're thinking about 19 times 4, you want to think about this as adding up 4 groups of 19 or adding up 19 groups of 4. Like I said, there's one model that is just kind of looking at piles, 4 piles of 19 objects or 19 piles of 4 objects. But we're going to look at some more of these structured, some more structured ways of looking at it. So one way is to model it on a number line. And we're going to do this here. I've already built a number line. And you might notice that I have only 5 boxes for 10. That's because my grid doesn't go wide enough in order to make it so that I could do 19 times 4 where every box counts as 1. So in this case, really, I have the tick marks are going 2 per square. Or not tick marks, but I should say the spaces that represent 1 unit goes 2 per square. Or another way of saying this is that every square represents 2 units. So when I think about 19 times 4, I'm going to start with 4 groups of 19. So my first group of 19 is here. There's 19. So that would be my first group of 19. And then my second group of 19 gets me up to 38. It's just 1 short of 20. And so 20 would be, adding 20 would be here. So I'm going to add 19 to make it there. Adding, I should have, so in this case, again, I'm going from here and adding 20 would get me to this spot here. But instead, I'm going to go to 19, which is 1 short of that. Okay, so there's 19, 19, 19, 19. And this ends up at 76. The other way is to go 19 groups of 4. So 4 is 2 squares long. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, good. I counted right because 10 groups of 4 is 40. 11, 12, 13, 14, 15, 16, 17, 18, 19. Again, ending at 76. Okay, so that's one way of modeling is on the number line, and it shows, 19 groups of 4 or 4 groups of 19. One of the things that we have talked about is modeling multiplication in a grid gets you both of those representations at the same time. So if I want to go 19 times 4 in a grid, I'm going to go like this, and I'm going to count out, here's 5, 10, 15, 20. So the 19 would be 1 short of that. Here's my grid of 19 times 4. And here we see, like I said, that you can see 4 groups of 19 by looking at the rows. Here's 4 rows of 19. Or I can see 19 columns of 4. And one thing that is nice about, you can see it in both of these models, is that you can split up the multiplication. For example, maybe I want to do, I like 4 times 15 because I think about, there's 15 minutes in a quarter hour. So 4 times 15 is 60. Then that leaves another 4 times 4 is 16, so I can do it that way. Or maybe I want to do 4 times 10 plus 4 times 9. There's a lot of different ways I can do that. Okay. Now, another thing that we can do is in these representations, I am making a very strict connection between the length of my lines and the numbers that I'm working with, right? So we can also do this in sort of what I'm calling flexible number lines and flexible grids. So a flexible number line is going to represent the idea of that, of one of these number line pictures, but won't necessarily be as precise. So here's an example of how I might do a flexible number line. I might just say, well, 19 times 4 is 1, 2, 3, 4. I might just model it like that if I'm speaking about it very loosely. Or I might, if I wanted to be a little bit more precise about it and actually use the number line to think about how I would do the calculation, I might say, well, I'm going to think of 19 times 4 as 19 groups of 4. And so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that 10 groups of 4 gets me up to 40. And then another 5 groups of 4, 1, 2, 3, 4, 5. Let's do another 5 groups of 4 gets me another 20, so it gets me up to 60. So here's another 5 groups of 4. And then what do I need? I need 4 more, right? I have 10 plus 5, so in order to get 19 groups of 4, I go 1, 2, 3, 4. 4 more groups of 4, which is 16. This is going to be 20, 40. Okay, so that gets me to 76. So in this case, I am using the structure of the number line, I'm using the idea of the multiplication model on the number line, but I'm not paying attention to exact sizes. I'm pretending that the underlying size is good, but I'm allowing it to be not good. Similarly, we could do this on a flexible grid. Again, the idea of it is to make it seem like we're emulating this sort of grid thing, but without necessarily caring to make sure that it is exact. So 19 times 4, I'm going to draw a rectangle and I'm going to say it should be 19 long by 4, and maybe what I'm going to do is I'm going to split it into 10 and 9. 10 times 4 I know is 40, and 4 times 9 I know is 36. So 19 times 4 is 40 plus 36, which is 76. So this would be a picture of a flexible grid that, like I said, it represents something that is more precise, but I'm not necessarily worrying about making it precise. I'm just using, I'm imagining that grid underneath it without having to display exactly the grid. Now let me show one more example on multiplying on a flexible grid to just see how it can give you a little bit more of a visual on some more complicated operations. So I'm going to do 78 times 13, and I'm going to represent this, I'm going to represent this with a rectangle. This is very, very, very imprecise, but it's going to be 78 wide by 13 tall. Again, we're imagining that grid underneath. 78, there's a lot of ways that I could possibly calculate this. Maybe I actually want to extend this and go out to 80. I like the idea of going by 80. So this would be 80 times 13. And the 13, I think I'm going to split into 10 and 3. There's 10 and 3. So 80 times 10, yes, 80 times 10 is going to be 800. That's all of this stuff. And then 80 times 3 is going to be 240. Okay, this is going to be 240. So let me write those things down. 80 times 10 equals 800. And 80 times 3 equals 240. And so then what do I need to subtract off? I need to subtract off 2 10s and 2 3s. So let's subtract off minus 20. That's 2 groups of 10. So I'm going to take 2 of those off. and minus 2 3s. So I'm going to subtract 6. 2 times 10 is 20, and 2 times 3 is 6. These ones we are adding up. Those add up to 1,040. And these ones we're going to subtract. These add up to 26. And we're going to subtract those off. So it's going to be 1,014. Okay? So again, this is a flexible grid that allows me to do some calculations, but doesn't necessarily show every detail of the picture underneath.